So today we have somebody who's flown all this way from San Francisco to blow your minds. But don't let the Silicon Valley zip code fool you. He's actually originally from the UK. And for a fun fact, for fun, he walked on the wing of an airplane while it was flying in the sky. So Jason's the web AI lead at Google, where he's been for 14 years. And he's here to tell you something a little bit more than just buzzwords, but real tools that you can use for smarter, faster, and more privacy-friendly experiences right from your browser. So his talk, the client-side web AI agents for building smarter user experience for the future. He'll be talking for about 20 minutes, and then he'll have about, or maybe 22, I think is what we agreed on. And he'll have about 10 minutes for live Q&A. So there's some couple microphones back there, but we'll also have some people running around, so you can raise your hand. And it'll get a little interesting. He brought some limited edition backpacks for whoever asks the most interesting questions. So get those questions afterwards. And if you weren't able to ask your question, he'll be in the WP Cafe afterwards, which is just right outside and to the right. So let's give a big round of applause for Jason Mays.
All right. Hello, everyone. I'm Jason Mays, Web AI Lead at Google, for our teams that focus on the art of running machine learning models client-side in a web browser. Today, I've come to share a story about the future of the internet itself and why you should start investigating agentic behaviors on device within the browser in JavaScript to gain extraordinary abilities for your existing web applications, while also enabling privacy and lower costs for your businesses as users' devices continue to get more capable. In 2024, the web AI community progressed towards a smarter web that was more powerful than ever before, like this prototype that enabled videos to literally watch themselves for you, extracting useful video frames in real time to grab moments that matter automatically and could even work offline. Now, in this video, you can see I asked it to find frames with the words Jason Mays contained within them, or a person standing on a plane, which, as you heard, is one of my hobbies when not working on web AI. And sure enough, it extracts those frames along the bottom for me, entirely client-side, no server-side calls needed. But this, while smart, was not an agentic behavior. So what's an agent? At its essence, an agent is a system that can perform advanced tasks autonomously on behalf of the user by breaking them down into structured steps that it can complete without user intervention. An agent can dynamically select and use exposed tools, potentially many times in a loop, allowing it to interact with the outside world, filling in any missing knowledge it may need to perform an external action, to then complete each sub-step beyond the constraints that a core language model may have, that's ultimately driving the agent's internal thinking and logic. Now let's dive into this tools concept a bit deeper. While language models contain a vast amount of knowledge about the world, if you ask one what the weather is today in London, it will likely hallucinate an answer that might be wrong. Instead, you can expose a tool that fetches the current weather for a given city that the language model can then choose to call with the inputs it needs to get up-to-date information about the weather and then use that response in its own contextual history to perform that task correctly. Now, tools allow the language model to bridge the gap between itself and the outside world. An agent can potentially use many of them to interact with various external data and services, unlocking more powerful actions that could be used to help it solve the goals set. Now, the example shown here illustrates some potential tools you may expose for a holiday planning agent. Now, common types of tools include calling a function to perform some task, or taking an action via an extension to use an API, or fetching relevant contextual information from, say, a vector data store. Next, with regards to the language models used, this could actually be one or more large language models or even multimodal models to understand inputs beyond just text that are all capable of following instruction-based reasoning. Now, if multiple models are used, the orchestration layer may decide which one to delegate to for the current subtask being performed. Essentially, an agent can plan and define subtasks that it needs to complete to get a job done, choosing the appropriate tools in each step, whose output can be used as an extra context in its memory to then reason what it needs to do in future steps in order to complete them without constant human intervention. And it can even cycle through a chain of steps it chose to perform, potentially multiple times breaking the task down further to eventually complete the request. So, bringing this all together, an agentic system is typically comprised of one or more language models, a memory implementation, and one or more tools it can choose to call. Now, these key subparts are managed and coordinated by the agent runtime, or orchestration layer, if you will, that governs how the agent takes in external inputs, how it should loop to perform internal reasoning, and even assisting in calling the correct tools that the agent chooses to use based on structured outputs from the language model itself. Or it can enable an ability to ask follow-up questions to the user as needed, and may define valid stopping points to present the results back to the user at key steps. Now, complexity of the orchestration layer will vary depending on your implementation. So, how does this all tie into Web AI? Well, last year, I made a prediction that websites of the future may need to be AI agent compatible, such that you could just talk to them naturally to perform any of the tasks that they support, to get useful work done faster, without needing to learn arbitrary user experiences on different websites. I also predicted that sites that don't make it easy for agents to work with them may struggle to compete in the agentic AI age, just like how we had to support mobile versions of our websites in the past to stay competitive when the smartphone was invented. Now, today, I'm going to demonstrate a Web AI prototype that puts these agentic concepts into action to show you a glimpse of a possible future of the internet itself, whereby websites are designed to work interchangeably with agents and humans alike. I'll be using Google's 2 billion parameter Gemma model, entirely locally in a web browser, powered by our MediaPipe Web LLM library, to show you how you can upgrade your existing site by upgrade your existing site with agentic workflows by reusing your existing code, exposed as tools that the agent can use in a low-friction manner. Now, if all websites enabled these concepts, we could enable a smarter web for everyone. Everything you're about to see is captured in real time on a 5-generation-old NVIDIA 1070 graphics card, so these things will only likely get faster with time too. Let's roll the video. In this demo, we will simulate a flight search page similar to Google Flights to illustrate how this agent could work. Let's go ahead and attempt to book a flight using the AI agent microphone button exposed, but purposely not give enough information. Hey there, I'd like to go on holiday with my friend.
Where are you departing from and when? Is that a one-way trip?
Notice how the agent has already figured out that 2 people are likely going on this trip in the JSON output on the left. However, it also realizes that in order to use the website search tool, it needs more data to call that, so it's asked us a follow-up question too. Let's respond with what it wanted, but also include more data than it asked for to show how it can adapt to anything that the user throws at it. We'll be leaving from San Francisco, but can you pick a popular skiing destination in the French Alps for us to go to? We'll leave on the 5th of December and come back 1 week later.
What is your preferred destination in the French Alps?
I don't mind. You pick a town that's good for skiing in the region. So as you can see, even though I spoke to it quite a bit, it successfully extracted the data information, figured out what 1 week later actually means, and suggested the popular skiing destination of Chamonix, which is a great choice. As it knows that it now has enough information to perform a search, it goes ahead and calls my search tool with the data. Now in this demo, just for fun, I even get the LLM to generate fictional results too, just to show you how much knowledge of the world this tiny 2 billion parameter model has with no tuning. So at no point in this demo did I send any of the data back to the cloud, although in real life, a search would probably end up calling your cloud API to get the latest results from a real flights database. As you can see, it generated some realistic flight options, including some European airlines. Alright, now we've got some results. Let's show how versatile this is. You know what, we had a change of plans and an extra friend is coming, and we decided to go to Tokyo instead. As this is a special trip, let's make those seats business class, baby, and change the dates to better dates in autumn. So here I'm hoping it increments the passenger count to 3, sets seats to business, and destination should become Tokyo. I'm also hoping for some dates in the September to November range, and sure enough, it seems to have worked. Now, as I said, everything here is running entirely locally on my laptop's GPU, meaning that you could talk to it all day long and there'd be no inference costs involved. The only cost here is the initial download of the language model based on its size and the CDN provider that you're using, which is a one-off and it's cached for future page loads. All right, so pretty natural user experience there and lots of potential, right? Okay, so speaking of caching, I've also created a useful caching proxy library available on the link shown that you can all use when you're fetching large generative AI models from some server in just a few lines of code. This library makes it easy to fetch large binary files and then shards them into smaller chunks to fit within the limits of the client-side caching APIs, and reconstructs the binary blob as a data URL so you can pass it to any library of your choice at runtime as if it were fetching a remote URL. And this is how easy it is to interact with existing website functions you've already written. As you've seen, this can lead to an experience that's much more natural for the user versus having to learn a new user experience for every website they view. Not to mention, even a visually impaired person could use an interface like this too, just using their voice, making the website more accessible. So pretty cool, right? Now, if you're wondering how all this comes together, this diagram shows the key data flow for what I made in the web app that you just saw. The key thing to take note of is that the agent orchestration layer logic shown in yellow there just attaches to your existing business logic shown in green. And you can choose what functions from your existing web app to expose to provide it with the tools it can then use to get jobs done for your users. Now, on the page load, the web app is just downloading the large language model that I plan to use from cloud storage to power the agentic experience. And as mentioned, in this case, I'm using Google's MediaPipe Web LLM library to load the Gemma 2 2 billion parameter model and run it locally in my browser. Once loaded, I can register functions that already exist in the existing business application logic, again shown in green, as a tool that the agent controller then knows how to use, and call as needed to perform any of the tasks that the website supports. Now let's dive into that part just a little bit deeper. In my implementation, the agent is flexibly defined in my side panel on the right, as shown here, to make it easy to edit on the fly for experimentation at runtime in my demo. As you can see, I define a persona along with the functions I want to expose as tools just by using regular JS-doc comments that I've already got in my production code base and could likely be auto-generated to some degree in the future too. The agent is then aware of their existence to use as it needs. Now that the core pieces are connected, the Web AI app is essentially ready to go. A user can use their microphone to talk to the configured agent in a natural way using a lightweight speech input layer that I also wrote. The speech is transcribed and then routed to the agent controller logic shown in yellow, and then uses the loaded large language model along with the defined agent persona, the exposed tools that are available to use, along with the current user input. The LLM is then able to generate a response in a defined structured JSON format that the agent orchestration logic can interpret and deal with, such as asking follow-up questions if needed, or calling one of the tools until it has enough data to do what's asked of it, in this case, to book a flight. Now, in my example, a text-to-speech engine is also used to speak back to the user if follow-up questions are required. And in case you're wondering how it knew what JSON structure to use, I specified this in the agent's configuration too, whereby I gave an example JSON-structured output that I want it to always adhere to, so that my orchestration there can route its requests to the right tool as needed via a common known interface to expect at runtime. Now, I can change any of this at any point if I wanted to experiment with different personas or work with other APIs or functions that I've exposed, if I wanted to do that, and making it very easy to explore future options. And then finally, once enough information is obtained to perform the desired task, the agent can call the search tool exposed by the business application to actually find possible flights that match and bring back the results. Okay? Now, these results are rendered to the user interface via the existing logic in the web app itself that would have already been present handling search results in the non-AI version of the site. So you're just reusing code that you've already got in production. And of course, once the results are rendered, the user could make a new request to maybe apply further filters or change the destinations as they desire, ticking off this whole process all over again. Except this time, the agent has a memory of the prior conversation, so it doesn't have to ask so many follow-up questions. All right, so with that in mind, I can now reuse this same logic with a different web application that has different exposed tools. In the example shown here, I made a web AI DJ in just one day by reusing the framework that you just saw that works with public APIs for music services to show how versatile this can be. I even upgraded the text-to-speech engine to use a web AI model known as Kokoro for a more natural-sounding voice, as you'll hear. Now, you can try this for yourself on the link shown, but use good Wi-Fi. It's quite large. But for now, let's see it in action and play the video. Play me some music suitable for late-night coding sessions that's chill and not too many words. And sure enough, in this case, it's able to think about its knowledge of the world to pick some artists for the criteria I asked for.
All right, let's get those late-night coding vibes going with some chill tunes. To kick this off, Tycho's dreamy soundscapes are perfect for focusing.
After announcing the track, using the Kokoro Web AI text-to-speech model that's also running entirely locally, it then calls the Spotify API to grab a song for the chosen artist, which it then starts playing immediately. And just like that, in less than a day, I've got a brand new prototype just by changing the tools that it can call and giving it a different persona for how it should behave when talking to the user. All right. So, as you've seen, Web AI is the art of using machine learning models client-side in a web browser, running on your own device's processor, graphics card, or even NPU using JavaScript and surrounding web technologies like WebAssembly, WebGPU, or emerging web standards like WebNN for acceleration. And in some cases, the base AI model may even be built into the browser itself and exposed to JavaScript developers via emerging APIs for common tasks like prompting, summarization, and translation. In fact, Chrome is already working on built-in AI APIs running entirely on the user's device too. So this is also a form of web AI. And you can check their website for more details on those experiments. Now, all of this is different from cloud AI, whereby in that case, the model would execute on the server side and be accessed via some sort of API instead, which means you need an active internet connection to talk to the API at all times to provide those advanced capabilities. Right now, generative AI in the browser is in its early stages, but as hardware continues to evolve with more RAM available to both the CPU and GPU, we shall continue to see more powerful models ported to run in the browser on your device, enabling businesses to reimagine what you can do on a web page, especially for industry or task-specific situations. In fact, we could see smaller large language models in the 2 to 9 billion parameter range be LoRa-tuned for a specific purpose via the cloud, and then run on consumer hardware on the client side to provide agentic behaviors like you saw today. And we're now at the start of a new era, an agentic-powered internet that could really enhance your existing web presence for the services and products that you're already providing. And the time is now to start exploring how you could apply web AI agents to your industries, augmenting the strengths of both client-side AI and cloud AI together. So, consider using hybrid approaches with these smaller local models today. For example, imagine you've got a vector database of domain-specific knowledge up in the cloud. You could pair that as a tool with a web AI agent on the client side to provide critical context to answer a user's request, allowing you to get more advanced tasks done that otherwise the smaller model may not have known how to do. By using both web AI and cloud AI together, it allows you to get the benefits of both ecosystems. Now then, I'd just like to end by saying there are very few opportunities in one's life to be at the beginning of a new era like this. I, for one, remember when the internet came out for the first time. Yes, I am that old. And agentic web AI has the same feels as that, only magnified 1,000x. And I personally believe that in the future, we will all build AI-compatible websites like you saw today, whereby you have the option to just talk to them naturally via text or voice to perform any of the tasks that they support using an AI agent. What if every website had a publicly accessible file that's specifically written so that an agent can understand what tools your services can provide? That way, instead of the user having to manually figure out some arbitrary workflow or user experience, the agent can then use that knowledge to get the job done in seconds. And the browser is one of the best places to do this, as you're already signed in to all of the services that you love and use daily, enabling you to use tools from all of those services in one place. And we're now entering the age where AI agents are growing in popularity. So, I hope in this talk I've been able to provide all of you a tiny glimpse into the future as to why you should start investigating web AI today, because everyone here has a chance of a lifetime to shape the future of the industries that you will work in for this fast-growing client-side space. And I hope all of you will join me on this adventure. So, do tag me on anything you make at your company, or if you've got any suggestions or questions about any of the technologies mentioned in this talk. You can connect with me on social media using the QR codes on the slide. And of course, remember to use the WebAI hashtag if you make anything so we can share it and help get you some eyes on your work too. So thank you very much. I'll see you next time. And of course, it's now time for questions. Thank you.
Thank you. OK, so we do have 2 microphones on both sides, and we have someone that can run one as well. Any takers? If not, I have one, but I feel like that's greedy if I get to go first. OK. You want to try and yell?
Yeah, okay. Can you? Just seeing the Jason, you make the assumption that speaking very old name will be enough to answer any question that an LLM can see. So you presented the departure date and stuff. So do you have a structure like only the format of the JSON or web form?
So in that example there, so my website had an existing search function, and in order to use it, you need to give it certain parameters. So in that JS doc comment that you saw, it says which ones are optional, which ones are required, and some sensible defaults as well. So if you don't specify how many people, it will assume one, and so on and so forth. So if you've got reasonably good documentation such that a human could probably understand that, this LLM could probably understand that too, and actually just run with it, which is quite impressive. Obviously, for specific industries, you might want to fine-tune the model if you're finding that the prompt engineering is not enough to get the job done. But I would start with the prompt engineering first, and then go to other techniques if that's not good enough for your specific use case. But great question, and you've won yourself a backpack if you would like one. So would you please come up over here, and I'll give it to you. Yeah, or you can give it to him. Yeah, thank you. I'll keep that one there.
And I see another guy over there in a white shirt at the microphone.
Hi. First of all, thank you, Jason. That was a fascinating talk. My question is about, you mentioned in the Spotify example it would take a long time to download and be on good Wi-Fi. I was wondering if that's because the LLM model needs to download, and I was wondering if that could be sort of part of the browser itself? Like, what's the potential that could be included in Chrome or Firefox or any of the other major browsers?
Great question. So to answer the first part, so in this demo, for one time only, you are downloading a 1.5 gigabyte model, which you're caching locally, okay? And it sounds, as web developers, why would you ever do that, right? The question I propose to you is that if you've got a service whereby you're going to use that model daily or weekly over a long period of time, it will pay dividends to cache that model and then not use the cloud in that case, because you'll save money over long periods of time, right? But if you're going to use less than like 10 cents worth of cloud calls, then it makes sense to use the cloud. So for your business use case, you need to decide if that's worth doing or not. The next question that comes from that is, of course, what about the user experience? Are they going to run away when there's a 1.5 gigabyte download? So you can get around this by designing your user experience with this in mind. So maybe you start by calling the cloud and download it in the background in chunks, and then when it's available, you silently switch to the local model to save your money for the company and that kind of stuff. And then the second part of the question, please, was the second.
I think you just answered.
Oh, OK, perfect.
Awesome. Thanks again.
Thank you. Please come get yourself a backpack as well. Yeah, thank you.
We can go to the other side.
Oh, thank you. Yeah. No, the third one is just that one. Yeah, cool. Yeah. And the third prize is a Web AI notebook and some stickers, as I've only got 2 backpacks. But next person who's over there, yeah.
Yeah, so I'm wondering about, as we make websites AI ready, there are going to be older sites that may be great sources of information that aren't maintained and are not going to be web AI ready. So one is like, will we lose the prioritization of that better information? And second, why not use the AI to build the description for these like older websites that aren't web AI ready so that the agents can follow them?
That's an interesting question, and it depends what model you're using, if those sites might be indexed in the knowledge of that agent or something like that. But typically, what I'm showing today is to work with your site rather than just the whole internet or something like that, right? So I don't have a good answer for that today for how to deal with sites that might not be upgraded in this form. But I would argue that this is my personal belief, not Google's, just to be very clear, but I feel that in the same way we transitioned to a mobile web first, sites that weren't mobile ready tended to be a little harder to use on your smartphone, and people would just naturally not use them so much. So I think the same thing will happen as our kids grow up. They'll just be used to asking a question and getting a task done. And if you can't do that, it's like, why would I use that site? So I think we'll go through that transition over the next decade or so, maybe. And that's my vision of how the internet itself will change. I'm not saying it will go that way, but from what I see, just generally, it tends to be going in that direction already organically, and I think it's just going to continue along those lines, personally speaking. So, but yeah, great question. You can have the book if you want, so please come on up. Thank you. You got it?
Yeah. And I think we have time for one more, but just don't forget that he'll be in the WP Lounge cafe, afterwards. Here, sorry, I'm just throwing it around. If you guys have more questions. So last one for him.
Who's going? Or?
Yeah, last one.
Oh,
yeah.
I'll go to this side, I guess. So, yeah, thank you.
Hi, Jason. Thank you for the fascinating presentation. My question is, because the agents are entirely client-side processing, what implications or considerations are there for data security or for data privacy as we move into this new phenomenon?
Yeah, great question. So it depends which angle you're coming from here. So the fact that we're running the model entirely client-side means that none of your data is going to the cloud. So in that sense, it's very secure and very private, which is a lot of the reasons why we've got people in the medical profession using us today, okay? And of course, we can run other models, not just LLMs. We can do like segmentation and body pose and all the other good things too. So in that sense, it's very private. Now, if you're asking about model security, like can someone steal that model, then of course, yes. If you're running on mobile or web, any dedicated developer can decompile that and extract the model and take it. So you don't want to give your crown jewels models away in this case, but a general LLM like Gemma, which is maybe tuned to your industry's data or something, or combines with RAG to bring stuff from cloud that's more private, so you're not just getting it all in the model itself, could be a nice balance there, so you have the best of both worlds, if that makes sense. Yes. Cool, thank you.
And the considerations for any sensitive data from a user's perspective, I guess.
Say again, sorry?
And any considerations for sensitive data from the user's perspective?
It depends how your software is doing things behind the scenes. So if you're talking to my local agent and you're only using local tools, not third-party things that are calling in the cloud, then unless your computer itself is compromised, which is a bigger problem, it's completely private. So if you're calling third-party tools, then you'd probably want to expose that to the user, saying, hey, this agent's going to call the Spotify API or whatever, so just be aware of that when you do this. But I think as long as you put those disclaimers of what third-party tools you're going to be calling, then they can choose to use it or not. So, yeah.
Thank you very much.
And for those of you who didn't get any swag, I've got lots of Web AI stickers for your laptops and lampposts on the way home. So come find me afterwards, and I'll give you some of those. Thank you. Cheers.
And just real quick,